Good evening. Welcome to Lesson 4. Lesson 4 is on text parsing. Text parsing is the phase that we do after we have collected the data either from the internet or from our database. Now, what do we hope to achieve in this lesson? We want to understand what is text parsing and why are we doing it. We also want to know how to do it in text miner. SAS Text Miner, which is a plugin in SAS Enterprise Miner. And in text parsing phase, there's a few tasks that we need to perform, and we want to understand what are those tasks and why are we doing them. So we are at text parsing, right? As you can see that there are quite a number of tasks that we need to do, and for the rest of the lesson we'll go through each of the tasks and why we are doing it, and hopefully you can complete the lab exercise to get a feel of the hands-on. Now, text parsing, text filtering, and text transformation, they are all part of the data preparation phase. However, this transformation is not linear, right? The transformation actually takes place within the text parsing and text filtering phase. Okay, after text filtering, we can say that the data is transformed into a structured manner and is ready for mining. Okay, parsing is derived from a Latin word. It means to identify the parts of speech. Now, it is the first step that we convert from unstructured data to a structured form, like the spreadsheet. So there are a few tasks that is involved in text parsing. The first is tokenization. Second is the normalization of tokens. And the part of speech tagging. Now, when we say token, it means words, or sometimes we use terms. Let's talk about tokenization. Now, involve a stream of characters, such as a sequence of text, of sentences in the text document, and basically breaking them down into words or a phrase of words. Number, punctuation, depend on the content of the document. So when we say a term, we are referring to the word. Okay, a term and a word is identified during this process of tokenization, and the term need not necessarily be just one word. It can be a group of words. As you can see from the example here, perfect camera, it is a noun group. So it can be a compound word. So this actually what happens, during tokenization, you have the text here, and basically you break them down into what we call the bag of bags, bag of words, right? Now in this particular case, we are just using a frequency count to record how many times the word appears in the corpus of documents. Now, typically, the process involves applying commonly accepted delimiters. All right, that means we define what we want to define as the delimiter between words. Right, it can be a comma, it can be a new line, or it can be just a full stop. For example, we have this sentence here: I love eating chocolate, but I'm worried about many calories in each bite. So here the delimiter is a space, right? So the number of tokens is the number of words in the sentence. In this case, there are 15 tokens. Now, the purpose of the various punctuation characters is also deciphered during the text parsing activity. Okay, although this process sounds very simple for human, however, it is difficult for computers to do it. Let's look at an example. Now, for example, if I have this digit here, 2566. Now, is this one token or two token? If we define the delimiter as a comma. Now, to us, it's quite easy in terms of for human to read. However, for computer, it can be quite tough. All right. Apostrophe. So is this one or two token? Or dash, if dash is the delimiter. So is this one token or two token? So by the human view, it is actually one number, right? But maybe the computer may interpret as two separate digits. Okay, after tokenization, the second step is normalization. Now, basically, the whole purpose of this activity to normalize the token is to reduce the complexity of the words by reducing its variance to its root form. For example, we have words like play, plays, playing. We want to these words actually have the same meaning. They are just variants. So we want to normalize it to the root word, which is a play. Because in text mining, we are not concerned about uh, singular or plural, but we are concerned about the meaning of the words. So there are two techniques that we normally use for normalization. One is stemming, the other one is lemmatization. Now in stemming, basically we reduce those words that are variants of past tense and present tense. To is present tense. Or if it's singular or plural, if it's plural, we reduce it to singular. Okay, as you can see, the dogs will be reduced to dog. Run, ran, reduce it to the present tense, run. Okay. Okay, so the whole purpose is that we actually cut down the variance of the same word to its base word, so that in total we reduce the number of words that we derive from the corpus without losing the information. So normally we use an algorithm called the stemmer. Basically, it's a program that we define the rules of how we're going to do the stemming. Okay, for example, this is the result of text parsing in SAS. So you can see that words like lower or low, they are being thrown away. So because they are actually being reduced to the base word low, okay, which is kept for the next phase of processing. Same thing for words like hand, hands, or hand. Okay, but do take note that some words can play the role of adjective and noun, so they are not the same in terms of its meaning. So this one, they will not be reduced, right? And we will come back to that, okay, when we come to uh, speech tagging. So the second method in normalization is lemmatization. Now, basically the idea behind lemmatization is to reduce words which may look different in writing, but they have the same meaning. Okay, for example, teacher and lecturer. The words are spelled differently, but the meaning the root meaning is the same. Both of them are in the teaching line. So we can actually replace the lecturer by teacher. Okay, so we cut out one words in the original corpus. But to do that, we need to make use of what we call the field of study, morphological analysis. Basically, it's a study of how the words are being formed. Okay, now morphological analysis is a field by itself, but just to give you an idea, okay, normally in the analysis, they decide how the words are being formed, or rather they analyze how the words are being formed. For example, the word unhappiness, right, consists of three morphemes. Okay, I call it morphemes. Okay, morphemes are what we call the smallest grammatical unit of a language that has meaning, right? But there are different morphemes. Some are free, some are what we call bound morphemes. Okay, like un, or nurse, although they are meaning by itself, but they cannot be used by themselves. They have to be bound to a free morpheme, uh, like the word happy, right? So by looking at how words are being formed, basically we try to understand and the root meaning of different words. And in lemmatization, basically we are finding words that have the same meaning, or we call it semantically equivalent. Something like synonyms, all right? Synonyms are different words but have the same meaning. Okay, for example, vehicles, automobiles, cars. Basically, they are variants of the base word car. So actually, in this task lemmatization, we can actually reuse these two words, vehicles and automobiles, to just car. So we cut down two words from the original corpus, and yet without actually losing the meaning, right? So in sense, it allows us to be able to decide whether we want to stem or use synonyms in our text parsing, right? So yes and no, whether to stem the words, or we can use our own set of synonyms, uh, and this is normally in very specific business domain that we use different dictionary, right? For example, in medical, they have their own terms. They are actually equivalently the same. Okay, this is another window from text parsing in SAS. Now, what you see here is all those terms that has been extracted, okay, for the next phase of processing. Now, what you see here, uh, those terms that has been have a plus sign in front, those are the terms that has been normalized to their root word. So all their variants are being thrown away, right? Being thrown away. Now, after we have normalized the bank of words that's been extracted during tokenization, we want to further redefine those words in terms of their role in the corpus, right? So we are at this third step, the part of speech. In this task, we actually want to define what role does each of the term or word play in the context of the document. So a word, the same word can be a noun or it can be a verb, depending on the context. And to us, human beings, they are different. And we want to be able to make sure that the computer can also do the same, right? So the computer shouldn't be treating the same word uh, the same unless it, you know the context, right? So in the part of speech tagging, it is the task of labeling each token or word in a sentence with appropriate part of the speech. For each word in the sentence, the algorithm decides whether it is a noun, verb, adjective, or adverb, preposition, conjunction, and so on. So when the algorithm passes a sentence, it will look at each word and decide the role that it plays in the context of the document, and the relationship between the words in terms of its role are then captured internally. Okay, internally is being captured as a tree structure. So like this one, the sentence, Bob is educating students. So Bob is a noun, right? Is an auxiliary verb, educating is a verb, and students is being identified as noun in this context. Here is also another example, right, where a sentence is being break down uh, and define its role in the context of the sentence. Now we don't really have to manually do this, right? Most of the software uh, will do this for us. They will be able to recognize the word in its context and define its role in the grammar. Now, the part of speech tagging can be very complicated because we know that the same word can represent different parts of speech depending on the context. For example, the word institute. Now you know that it can be a verb or a noun, right? Or let's say the next sentence, I make her dark. Now, even between humans, we may not exactly understand what it means because it's quite ambiguous. It can mean three meanings, right? Okay, when I say I make somebody dark, uh, it means that this this person actually are being made use of, right? This is in the colloquial meaning. The other one is I make her dark. It can be literally a duck. Okay, maybe make a toy duck. Or the duck here can be a verb, right? When you make somebody duck in the verb sense, it means that this person is trying to quickly run away, okay, escape from a situation. Okay, let's look at the next sentence. The man saw the boy with a telescope. Okay, so who actually has the telescope? The man or the boy? So to resolve such ambiguity in interpreting the sentence, okay, the software will have to understand the adjacent terms in the sentence or in the paragraph in order to identify the part of speech correctly. So in other words, you need to know the context. So all these are done and factor into the software. So in SAS, if you look at the text parsing node, there is on the property panel for us to either to define the parts of speech. Alright, so if you click on the three dot here, there'll be a pop-up window for you to select which parts of the speech in a sentence to ignore. So those highlighted one are the part of the speech that you want to ignore, right? So depending on the content of the document and what you are trying to analyze, okay, you may want to adjust this repeatedly, right, until you get a good model. Now let's look at this example here. Okay, the term institute. Now if we choose not to ignore any part of speech, then there will be 4,212 times that the word appears in the corpus of documents. Okay, so out of which 21 words are linked as a row of the preposition, right? And 6 words are actually verb. But if we say that we are only interested in the noun of the word institute, we can just ignore it. Okay, so we can ignore the parts of the speech, verb and preposition by defining here, by highlighting it here. Then what we get will be just a noun. All right, so this is how you actually control the parts of speech that you want in your analysis. Okay, this is the result of the row of each term after they have been tagged with the part of speech. Sorry. So you can see that after the text parsing, the results will also define the role that each term will play. All right. Now this attribute here means alphabet, right? Alphabet. Now after we're done the part of speech tagging, the next step is actually to filter off further terms, right? So that we get more terms that we want to keep for the next part. So now by the time in text parsing, some of the words like the, of, be, all these which have no significant value, they will be actually be thrown off. All right, as you can see from the result here, under, for example, n, it occurs this number of times, and really it has no value, so it's being sort of thrown away, so that it will not be carried to the next phase of processing. So if you look under the column keep, you can see which one is being kept, which one is being thrown away for the next phase, which is text filtering. Now we can further define the results after part of speech tagging, because some of the words, whether they are rejected or accepted, will depends on whether the words can be found in the dictionary, right? So we use what we call the stop list and the start list. The stop list consists of words that we actually want to ignore, right? But it's being kept after the text part of speech tagging. A start list contains words that we actually want to include, but it's being rejected or not kept after the text part of speech tagging. For example, the word shook. Now, shook, we know that it's not found in the dictionary, but we know that actually this is a colloquial language, which means good. So when you have when doing the analysis of food, for example, you may want to keep this word. But then if we just let the software do it, the software will actually reject this. So we want to put back this word into the list of terms that's being kept for the next phase. Same thing for the word COVID-19. Probably you will not found in the ordinary dictionary, right? So likely it will be rejected after the part of speech tagging. But we know that this is an important word in the context of the current situation. So we may want to put it back from the rejected terms. So in sense, we actually have, again, in the text parsing note, to define our stop list and start list. Okay, this will help us to further refine the terms that has been produced, the terms that have been kept and rejected by after the part of speech tagging. So you can put in your own stop list and start list. Alright, for example, in here, in the stop list, I want to, I think that all these words I don't want, right? It's not necessary. So I put them in the stop list. Now you can actually put them one by one, or you can upload a list uh, from a document. Okay. Now this one you can refer to your lab exercise. So so this is a list that these are terms that I do not want. So when you run again, all these terms actually will be rejected. You can see it's not keeping. Yes means keep, N means no need to keep. Right? So you don't want to bring these terms to the next phase of processing. So this is a summary of what we've done today. So quite a fair bit of things. So basically in text parsing, we are trying to process the words. We extract out the words from the original documents, put them into a bag of words, and then we refine it so that we only want to have those words that are significant, and yet we don't want to lose the original meaning information in the documents. So we stamp out words and reduce them to the base word, right? For singular or plural, we just make them into a base word. Okay, for limmatization, we actually reduce those words that are of same meaning to the base word. Part of speech, we define the role of grammar, the wordplay in the documents. And stop and start list is for us to refine the bag of words further. So the output of from the text parsing is really a collection of terms that has been much reduced from the previous phase. All right, that means the text import phase, collection phase, and this term has been normalized and filtered. All right, so the output will then be ready for the next phase of processing, which is the text parsing. Now, I will talk a bit more when it comes to the coursework. In the coursework one, you are required to perform some of these tasks in a given document, a given set of documents. Right? Thank you.